Okay, we're doing an example from 5.3, and we're finding the definite integral. Definite means we have endpoints. We're in a specific chunk of the graph that we're finding the area under the curve. And remember, integral, area under the curve, can't say that enough. Make sure you know that. We've got this specific chunk, and so that means we can get a specific answer. We're not going to have an equation for the answer here. We're going to have a number. So anytime you have a definite integral, which means you have the values here on the integrand sign, you're going to get a number for the answer. So the first thing we do here is we simply take the antiderivative. So of course this is 1, so we add 1. This becomes x squared, and then you take this and you go 1 over the exponent, so 1/2. Then what I'm going to do is I'm going to take the values from my integrand sign and put them here so I know what to do. And then what you're going to do is you're simply going to plug these in and you're just going to subtract them from each other. If my camera can continue working. It's mad at me all of a sudden for some reason. I guess it doesn't like my definite integral. Okay, so what I'm going to do is 1/2 square root of 5 squared minus 1/2 2 squared. Now obviously if this was longer than 1, this wasn't a monomial, this was a polynomial of some form, you would want to put parentheses around this because this negative would apply to all the terms. Now obviously you have several options here, and my camera is just darn mad. Let's see if this works. Third time's a charm, right? You have several options. Obviously you could do each of them separately and then just subtract the numbers, or you can distribute the negative sign. But make sure you realize this negative applies to the entire thing. So if you're going to do that, you have to do all of this, then all of that, part of order of operations here. So this becomes 1/2. The square root of 5 squared is simply 5. The square root sign and squared cancel each other out. 1/2, 4. So this becomes 5/2 minus 2. Actually, I'm going to write this as 4 over 2 just to make this easier. So this is 1/2. So my area under the curve is 1/2. So let's go back here and 1/2 and check the answer. And that's all there is to it. So really all you're going to do is you're going to take the antiderivative of whatever this is, and then you are going to simply plug both of these in and subtract them. Start at the top. So subtract the top from the bottom. So the top is the first number, the bottom is the second. So just simply work down.